Is this thing on? All right, welcome everyone to another episode of the Summits Podcast. As you can see, we are not in the studio today. We are in West Lafayette, Indiana.
What does that mean?
You tell me. I'll let
You let me?
Yeah.
Oh, okay.
Yeah.
Well, we are actually at Purdue, and I'm surprised. Let me just. Yeah, Vince isn't on fire yet, but there's still time. We're still here for a little bit, and so there's still time for something to happen to you.
I did not wear the candy stripe pants today, even though I was.
You did wear
there
Purdue
was a
shoes.
wager as to whether I would or not.
But not underneath these. You're not gonna.
No. I thought about that. Should have done that.
Should have done that.
We are privileged today to have Dr. Phil Lau with us. Dr. Lau is the Presidential Scholar for Drug Discovery and the Ralph Corley Distinguished Professor of Chemistry. Did I get that right?
That's correct.
Perfect.
Yeah.
Nice.
Welcome to the Summits Podcast.
Thank you. It's a pleasure to be here.
Why don't you, if you would, give our listeners and viewers a quick background on your history. Where have you, how did you work your way into Purdue, and how long have you been here?
Okay. Well, I grew up in West Lafayette. My father was a faculty member here at Purdue. I played basketball on the West Lafayette High School basketball team, but wasn't a very good scholar. I went to Brigham Young University, actually on a basketball scholarship, and only played 1 year because I really wasn't very good. And from then went on and got my PhD at the University of California, San Diego.
Okay.
And after that, I obtained a 1-year postdoctoral training, exercise in Massachusetts, and then came to Purdue as a faculty member in 1976. I've been here ever since, one of the longest lasting faculty members on campus. And my research interests began really in fundamental chemistry and gradually migrated into drug discovery. And I've been working on developing drugs for treating all sorts of different human diseases, from cancer to autoimmune diseases, fibrotic diseases, CNS diseases like Alzheimer's, even infectious diseases and broken bones ever since that time. And I'm sure you know that we just had 2 cancer drugs approved by the FDA, which is remarkable even for a large company.
Yeah, I was going to hit on that. You have a long list of various awards and recognitions, but you mentioned the 2 most recently.
Yeah.
What can you tell us about those, or help educate our viewers on what those were?
Sure. We initiated this research with the intention of making drugs safer and better. And our approach to that was to target them very selectively to diseased cells, avoiding uptake by healthy cells. So the first drug that just got approved back in late November 28th of last year, is a bright fluorescent light bulb. It's a fluorescent dye that is targeted very selectively to cancer cells. It is taken up by the cancer cells. It clears very quickly from all normal tissues, and when the surgeon goes in to perform surgery, the cancer cells light up like a bright light bulb, and allows the surgeons to find and resect the cancer, whereas otherwise much of this malignant disease tissue would remain in the patient. I don't know whether you know this or not, but 15 to 50% of all cancers that recur following surgery recur right in the bed where the surgeon removed the malignant nodular lesion, meaning that he or she didn't find all of the cancer and left some behind, and that can grow and kill the patient. And our data show in ovarian cancer that 27% of all patients that were examined or underwent surgery with the aid of our tumor-targeted fluorescent dye, they were able to find extra disease that was otherwise invisible or undetectable by the surgeon. And of course that can save lives, so we're very optimistic it's going to benefit a lot of patients.
Yeah, absolutely. That's awesome.
Did you say, does that require like UV light then? Is that what it's, or what is it?
It's actually, that's a great question. It's actually near infrared light. It's light you can't see with your eyes, but it's light that penetrates solid tissues much more readily than visible light or UV light. The UV and visible light, if you shine it in your hand, you don't see anything out the other side. But with the near infrared light, if you shine it, you can see it out the other side. So we can see malignant tissue deep in the patient, and this enables us to find a lot more of the diseased tissue.
Wow, that's amazing.
What was the second project that you mentioned?
Okay, the second one is a prostate cancer targeted radioactivity. And what we have done here is, again, used our capabilities of designing molecules that will home in very specifically on cancer cells. And we've piggybacked onto one of these homing molecules a very cytotoxic radionuclide, is what it's called, a radioactive metal.
Okay.
And so that's concentrated very selectively in the cancer cells. It avoids uptake by healthy cells. As a consequence, all of the lethal activity is focused right on those malignant cells. And the data, we sold that to Novartis, and Novartis finished the phase 3 clinical trials, and they reported that the therapy led to extended the lifespan in 38% of the patients, and by 38%, excuse me, lifespan was extended by 38%, and progression-free survival, that is the time until their disease progressed, was extended by 60%.
Wow. It's maybe a dumb question, but how is that delivered?
That's just infused into the vein, and the patient goes in and receives an infusion and goes home.
Would that be to potentially replace surgery, or in addition to, maybe?
It'd probably be a supplement, an adjuvant to surgery. In other words, in all fairness, the only absolute cure for cancer is to remove it all, cut it all out. But this second drug was tested in patients. All of these data I just recited are obtained in patients that were refractory to everything else, and so to be able to take patients that don't no longer respond to any of the current therapies and give them a significant life extension and have the disease suppressed or even eliminated for a significant period of time is a great benefit and blessing to these people. So, and it comes with very, just limited toxicities. It's really quite benign because it's targeted and it's really concentrated in the cancer cells and avoids uptake by the healthy cells.
Yeah, cool. Are you able to give like a, mention these two drugs, able to give kind of a high level of how from idea or inception of this drug or what you're trying to accomplish, how does that work here at Purdue and then find its way into being purchased by a company and then going into clinical trials?
Yeah, briefly, the conception has to occur in the academic lab, like in our lab. I thought of these ideas, and we then engage graduate students that are here for training in the sciences that we excel in, and I have quite a number of them in my lab, or postdocs, and these are the individuals that have already obtained their PhDs and want to obtain further training. I have quite a number of them working in my lab, and so I'll assign them the project to explore the possibility of, for example, targeting a therapeutic radionuclide to cancer cells. And if the project works, then we try to obtain outside funding, often from companies. But in my particular case, I've kind of focused on founding my own company. So I've founded 7 different companies, and I patent all the technology through Purdue University. That's the that's required in our contract when we sign up.
Yeah.
But then I go to the university and ask if I can license it back into a company that I founded, and they've been very accommodating in my requests there. And so in both cases, the technology was licensed back into one of these 7 companies, and the company then goes to the private sector and raises money. And in the case of the drug for the radiotherapy, we raised somewhere near $500 million to run that through the clinical approval process. In the case of the fluorescence dye, the costs are much lower, and so we only had to raise about $125 million for that. And that money is then used very frugally to try to test the new drug in real patients with real cancer. And these trials are run all over the world. We were running them at more than 100 sites, not just in America, but in Europe and even in the Far East. And the results are then collected at the end. And in the phase 3 trials, the registration trial or the critical trial for FDA approval, the results are generally blinded to the physicians, so they don't know what they're administering, whether it's a placebo or whether it's actually the therapeutic drug. And then at the end, the results are unveiled, and everyone is able to look and see, did it work or did it not work. And as I said, we saw a 38% extension of lifespan with the radioactive drug. We're still looking at lifespan extension data for the fluorescent dye that enables the surgeon to find more. But as we move through different cancers, we're finding that it's very successful in helping surgeons locate and resect otherwise in undetectable cancer tissue. And so the anticipation is that it's going to also significantly extend lifespan, but that's got to be demonstrated still.
I would think that type of product also is something that could be scaled pretty easily, so to speak.
Yeah, well, the advantage is that there's virtually no toxicity with it. It's just a small homing molecule. It has no component that kills. It just is a bright light bulb.
Right.
And so, it is injected, floats around. If it is captured by a cancer cell, that cancer cell glows. If it flows out of the body, all you have is some fluorescent dye in the toilet.
Right.
And that's the end of it.
There you go. Well, the Heroes Foundation, via its Catherine Peachy Fund, has made gifts to Purdue in 2021 and will be again this year. What would be your vision for the cancer research that is being done here at Purdue? Because you guys do a variety of research, and it's not just on one particular area of cancer. You focus on all different types. But if you had to kind of give a general vision for what you would like to see continue here, what would that be?
Well, the process of developing a therapy that can kill cancer cells and extend lifespan is very involved. First of all, one has to understand the basic processes that lead to cancer, and then we try to interrupt those processes with chemicals or drugs. In other cases, we try to understand what factors allow cancer cells to survive in a patient, and then we try to block those processes. I think Purdue excels in these basic aspects of research. We don't have a medical school here, so it's not easy for us to take those drugs and test them on patients. It's even more difficult to get cancer tissue from real patients. And so my hope for this would be that the money would be focused on the really productive labs at the university that are identifying the best targets for people like me to go in and make a drug that'll treat that target. And so there's a lot of different steps in that, a lot of different skill sets that are involved. And Purdue has representatives or very good faculty members in all of those required skill sets. And I think that basic science is the area where Purdue can excel and make the greatest contribution to curing cancer.
Yeah. You've been doing this for a few years.
Yeah.
What still gets you excited every morning to come in and continue to do the work that you're doing?
Well, that's a great question. I have some strengths and weaknesses in my brain. I learned it over 46 years of being a faculty member at Purdue, and I find that I come up with ideas very easily. I look at data and I see things that other people don't see. On the other hand, I don't remember them very well.
Sounds familiar.
It's just, it's just the way I'm built. Okay.
Yeah.
I write them all down, and I have piles of ideas that, and I read through them. And every time I read through them, I think, "Gosh, those are really good ideas," and there are. So, I would like to continue exploring some of these ideas that I have. I think there's great opportunities to reduce morbidity and mortality in humanity, and I think we can do that. We've talked about 2 of our drugs, but I have a pipeline of probably 20 other drugs that we're developing right now. We have a malaria therapy, for example, that has finished phase 2, and we're getting 88% cures in 24 hours and nearly 100% in 48 hours, which is remarkable.
Wow.
The trials aren't being done here in America because there's no malaria here.
Yeah.
But they are being done in Vietnam and Laos and countries where drug-resistant strains of malaria are emerging very prominently, and it's getting pretty scary what might happen if we don't begin to take care of those. So, we're working on autoimmune diseases, on Alzheimer's disease, on macular degeneration, on bone fractures, on multiple sclerosis, on viral infections like hepatitis B and HIV and so forth. So I would like to have the opportunity to continue those investigations and hopefully contribute to the reduction in pain and suffering associated with these pathologies. That's my goal.
Yeah.
Do you have a particular cancer story that you'd want to share?
Cancer story.
Well, we all kind of have our own cancer stories in some way, shape, or form.
Well, I don't have any miraculous outcome that I'd like that can really inspire, but I've had a number of relatives in the family die of cancer. My father died of mesothelioma.
Okay.
That's cancer caused by asbestos, and pretty much exclusively that. And he worked in Lilly Hall here on campus, where the fireproofing was thoroughly performed with asbestos.
Yeah.
And so, my grandmother on my father's side died of pancreatic cancer, and my great aunt also had breast cancer and died of that. So we have quite a history of cancer. I hope to be able to reduce the incidence for other people with some of the research we're doing.
Sure. Well, we appreciate all the work that you're doing here at Purdue and in the state of Indiana to help not just Hoosiers with cancer, but and beyond. All right, guys, that wraps it up for this episode here at Purdue University. I've been also placed a small wager on myself to say boiler up, so you're welcome.
There it is.
We appreciate you guys listening in. Again, if you're watching on YouTube and you haven't subscribed, we'd appreciate it if you did so. Also hit that little notification bell so you can be alerted when new episodes drop. And until then, beat cancer.